First, we're going to start with the naming conventions of the triangles, and we can label any side A, B and C, but it's important that we label the angles opposite to their side lengths with their corresponding letter. So I label A opposite side length A, and here we've got angle B, which is opposite side length B, and angle C up the top there. So we can use the sine rule anytime we have an angle and side length pair. So in this case, we've got the side length A with its pair angle, or the one that's opposite to it. So we're also given angle C, and that can help us find a side length C down there. In this case, we've still got the angle A and side length A pair, and we're given side length B, so we can use that information to find this angle B down here. So the sine rule is when you have sine of A over side length A equals sine of B over side length B equals sine of angle C over side length C. The other thing we can do is take the reciprocal of that if we're looking for the side lengths. So if we're looking for the side lengths, we'd use this, or if we're looking for the angles, we'd use this one. We've got to be aware there's one case where we've got two possible options, two possible answers. It's called the ambiguous case of the sine rule. So when we've got two side lengths and an angle, right, both of these triangles have length, side lengths of length A, both have side lengths of length B over here, and both have angle A, but there's two different triangles. If we overlay those two triangles together, we get an isosceles triangle formed with side lengths A. Okay, so any time that we use the sine rule to find angle B, just in the corner, we're always going to find the acute angle down here. Okay, so if we're looking for this triangle, which is an obtuse angle greater than 90 degrees, so to find that, we need to just go 180 minus this angle here. There's also the cosine rule. The cosine rule we can use when we've got two side lengths and the angle in between those side lengths. So the angle in between A and B is angle C. There's also another scenario when you've got all three side lengths and no angle at all. That's when we can use the cosine rule as well. There's two forms. The first form is written out like this. C squared equals A squared plus B squared minus 2AB cos of C, angle C. Or if you've got all three side lengths, we use this one down here. Okay, and that will find this angle up the top here. We can also change any of the variables around to find any of the angles. If we've got the cosine rule, we can also find the area of the triangle. So in this case, where we've got both the side lengths and the angle between, we can use half A times B multiplied by sine of C. That will give us the area of the triangle. If we've got all three side lengths, we can use Heron's formula just here, or the classic half base times height. In this example, we've got a pair, a side length angle pair with the 12 centimetres and the 70. So we're going to use the sine rule, and because we're looking for a side length, we're going to use the ones with the side length on the numerator. So if we plug in our information, we've got x over sine of 60 equals 12 over sine of 70. So to solve for x, we've got it divided by sine 60 here, so to undo that, we'll multiply that up, so move that up here, so we'll get x equals 12 multiplied by sine 60 over sine of 70. If we plug that into a calculator, we'll get 12 sine 60 over 70 equals 11.06. Example 2, we've got find the value of x here. So again, we have the angle and side length pair, the 5 and 23, opposite angle and side length. So we're going to use the sine rule, but we're looking for the angle. So with the angle formula, we will have the angles in the numerator. So if we plug in our information, we've got sine of x over 8 equals sine of 23 over 5. Okay, so we're trying to solve for x, get x on its own, so we need to multiply both sides by 8, moving the 8 up there, and then taking the inverse of the sine. So doing two steps at once, we'll do x equals inverse sine, big brackets, of multiplying this up here, 8 times sine of 23 over 5. So plugging that into the calculator, that gives us 38.7. However, in this case, this angle here is an obtuse angle, so it's more than 90 degrees. So we might have one of those cases where it's an ambiguous case. And the way we check that is to say the calculated angle 38.7, that's greater than the initial angle of 23 degrees, so we could have a case for that ambiguous case. So because we're looking for an obtuse angle, we'll say this isn't the angle, so we need to do x equals 180 minus 38.7. Putting that into the calculator, we'll get 141.3 degrees. In example 3, we've got two side lengths and the angle in between, so this is a case for the cos rule. And because we're looking for a side length, we're going to use this form of the cosine rule. So plugging in the information, we've got c squared equals a squared. Now it doesn't matter which one we call a, 53 squared, so we'll make 53 the value for a, plus 48 squared minus 2 times 53 times 48 cosine of 38 degrees. So all we need to do is plug that straight into the calculator. There's no ambiguous case of the cosine rule, so we can be very confident that our answer will be 33.22 centimetres. In example 4, the triangle looks exactly the same as the last triangle, except this question is find the area. Because we've got the two side lengths and the angle in between, we're going to use this formula for the area. So plugging in that information, the area equals half times 53 times 48 times sine of 38 degrees. And we plug that into the calculator and we get 783.1 centimetres squared.